Hi everyone. Today we are going to, we're going to go over the homework that was due today. So the first question I want to go over is it says determine if there's similar, congruent, or neither. So when I'm looking at these, what I do is I compare radius over radius. So that's 4 over 3. And then I compared height over height, which is 14 over 10.5. Since both of those are equal to 1.3 repeating, they are similar. Number 2, when I look at these, it looks like, hey, all the numbers I see are 18, 18, and 22. However, the shape on the left, the base is a square, so that is a square pyramid. And the shape on the right, the base is a triangle, so that is a triangular pyramid. Therefore, they are neither, because I can't have different shapes as the base and still be similar or congruent. Number 3, 2 similar cylinders have radii of 15 inches and 6 inches. What is the ratio of the surface area of the small to the large? So, oops, I'm just realizing when I did my work the first time, I did it backwards, so let me redo it. So I'm doing small to large, so the ratio of the similar figures is 6 over 15, because that's the ratio of their radii. So this is our similarity ratio. So when I'm finding the ratio of the areas, I square both, which gives me 36 over 225. I could also choose to reduce the 6 over 15 because those are both divisible by 3. So that gives me 2/5, which then would also be 2 squared over 5 squared, which is 4 over 25. These two fractions are equal. Number 4, 2 spheres have volumes of 36 pi cubic centimeters and 288 pi cubic centimeters. What is the ratio of the radius of the small to the large sphere? So again, I'm going to put small on top. So I did 36 over 288 pi. I entered that in my calculator as a fraction, and it told me that that's equal to 1/8. That is our volumes. So to compare volume with sides, I need to take the cube root of each. So I take the cube root of 1 over the cube root of 3, and that gives me 1/2. Now, if you didn't think to reduce it, you could, in your calculator, do the cube root of 36 pi over 288 pi, and it will tell you that that's also 1/2. The key that you got to remember is that when I'm going from volume to sides or radius, I take the cube root. Number 5, this tells me that 2 similar solids have heights of 35 and 25. What is the ratio of their volume? I want the large to the small, so I'm going to do the large one on top. So again, what I did is I did 35 over 25 in my calculator, and that told me it reduced to be 7 over 5. That's the ratio of our sides. So when I have the ratio of our sides, or our similarity ratio, I cube it to do the volume. So 7 cubed over 5 cubed is 343 over 125. Now I could have just cubed 35 over 25, and that would have given me 42,875 over 15,625. But that will reduce to be that 343 over 125. Again, if I have the sides and I want volume, I cube it. Number 6, 2 hexagonal prisms have volumes of 250 cubic feet and 2 cubic feet. What is the ratio of the height of the large to the small? So again, I have the volumes. So the first thing I did is I simplified it. So 250 over 2 is 125 over 1. And again, for the sides, I take the cube root of the volumes. So the cube root of 125 over the cube root of 1 is 5 over 1. Or on your calculator, you could have done the cube root of 250 over 2, and your calculator would tell you that that's 5 to 1. So if I have volume to get sides, I take the cube root. (16) Here we're talking about our suitcases. So what is the scale factor of the prisms? The larger. So I did smaller over larger. It didn't tell us, so you could have done either way. So the scale factor, I have to compare the length with the length. So it's 68 over 85, and that's just the answer there. For part B, we need to use that to find the volume of the larger suitcase. So the first thing I did for part B is down here, and that's that I need to find the volume of the small. So the volume of the small, I did 68 times 47 times 27, which gave me 86,292, which that didn't show up very well. Now, to compare the ratios, I cube it. So the volume ratio, I take my answer to part A and I cube it. So it's 68 cubed over 85 cubed, and that equals the volume of the small over X. I cross multiply, which gives me these really large numbers. I divide both sides by 314,432, and I get X equals 168,539.1 meters cubed. So that, and then our very last question is, what is the volume of the larger solid? So in order to find the volume of the larger solid, the first thing I need to do is I need to find the volume of the smaller one. So the volume of the cone is 1/3 pi r squared h. So I did 1/3 times 6 squared times pi times 5.7, which gave me 214.88. I rounded to the hundredth. Volume of the cylinder, I did pi r squared h. So it's pi times 6 squared times 7.2. Give me a volume of 814.30. My total volume for that is I add those two together and I get 1029.18. Now to compare, I need to find my similarity ratio. So my similarity ratio, I did the height over the height, or I'm sorry, the diameter, which is 12, or I'm sorry, I goofed that part up. So my diameter here should be 12, not 8. I don't know where I got 8 from. And my diameter here is 16. So my ratio, let's erase this. And then we're going to erase this part down here too. Sorry, I made a mistake on this one. So our ratio is 12 over 16, which I can reduce because those are both divisible by 4. So that's 3 over 4. So our similarity ratio of the sides is 3 over 4. So then our volume similarity ratio is 3 cubed over 4 cubed, which is 27 over 64. So to find the volume of the larger cylinder, I need to take that ratio, that 27 over 64 equals our smaller volume over X. I cross multiply, so I get 27X equals 64 times 1019.28, 1029.18, sorry, said that wrong, and I get 65867.52. I divide both sides by 27, and my volume is 2439.54 when I round to the nearest hundredth. I think we were only rounding to the 10th though, and that's centimeters cubed. So that is the end of the homework. Please use this to correct yours. If you have any questions, I'll be more than happy to answer them tomorrow.